approximations. They, like I've said a number of times, you show me a real straight line in nature. If everything in the universe, everything is expressed in motion, all motion expressed in waves, all waves recur. Every action has an equal and opposite reaction. So the greater the action, the greater the reaction. The greater the reaction, the greater the resistance. The greater the resistance, the greater the curvature. Because the universe is based off of equanimity, which Einstein left out in his theory of relativity, the balancing side of the gravity was caused by electric force. Electricity is always seeking a higher pressure condition. It spins northeast, it's trying to get to the center of an area, the center of a cone. But the next electric wave is coming, so it gets pushed out, and as it's pushed out, it gets to the vortices. And that's some on those pieces, those vortices. Now, instead of it spinning northeasterly, centripetally, it's forced to spin centrifugally, and it spins southwesternly. And it expands itself out, it decays, it keeps decaying until you get 4 magnetic waves that hit each other at 120-degree angles. At that point, they reconvert back into the electric field. And then they make their way back to their source again, whether it's the star, whatever star it came into. What happens when we get older? We expand at our equator, right? We get shorter at the top. Why? Because the electric force is pushing in and condensing, and the magnetism expands out at the equator. The electron field, the electrons, that's just discharged electricity, devitalized electricity coming from the sun, coming from the earth. It's the waste product from it. But it hits our magnetic field, and then it gets pulled right back in, it gets compressed again, and now it becomes electricity for the earth, and then it pushes itself right back out again at the equator. The equator is 5 miles wider than the poles. Electricity, Einstein left that out of his equation because he coupled electricity and magnetism together and didn't realize that electricity was the equal and opposite of magnetism. Electricity being the contractive field. You breathe in, that's a contractive thing. You breathe out, that's a magnetic thing, a radiative thing. But they use the term magnet as an attractor. But to magnify something means to what? Make it larger, increase the space. That's the work of radiation. That's what Walter Russell was talking about all those years. That's the work of radiation. It's the electricity between the things that pull them together. The Coulomb force that supposedly opposites attract and push each other away. If that was true, then hot air and cold air would seek each other out. They're the same substance, but just but in a different state. One is, they move in opposite directions from each other. Hot water and cold water move in opposite directions from each other. The reason 2 magnets seem like the North Pole is attracted to the South Pole, because if you had 2 rivers or 2 hoses with water coming out of them, and you pointed them at each other, what are they going to do? They're going to be pushing against each other. But they align to where the male enters the female and is able to come out. So they've been fooled by their senses. They've been fooled by their eyes and have missed the whole picture of it. Are you familiar with Khalil Gibran?
Yes.
He wrote a book, he wrote The Prophet, 1923, but he wrote another book called Sand and Foam. In that book, he told a story of a man who had been away from his family for 4 months working, and he was excited to come home. And as he was coming home, he knew that the mountain, when he saw the mountain, that he was close to home. So his 5 senses started having a conversation, and his eyes says, I see a mountain, I see a mountain, I see a mountain. And so the ears perked out and said, I don't hear a mountain. The nose sniffed and said, I don't smell mountains. The tongue tasted the air, I don't taste the mountain. And the other 4 senses started speaking among themselves, and they came to the conclusion that there must be something the matter with the eye, because they couldn't perceive it. But all of these things, we've been misled just because we've been fooled by our senses. Our eyes see 0.05% of the entire electromagnetic wave. We're blind cosmically, but we judge everything by what we see.
Mm.
And they've done that with science for so many years. You look at E equals MC squared. That talks about its expansion. It does not show how it's divided. If ever, you've never breathed in twice without breathing out. You breathe in and you breathe out. You charge and you discharge. There's no. So how is it that the breathing in, they're acting as if the universe is just expanding out, breathing out, and it's going to dissipate out, and they never include the contractive side of it, breathing in, because they were misled by Newton, who said everything moves in a straight line unless affected by something else. And we know that not to be true. But they built the entire two-dimensional plane, the Euclidean space that we live on, that we work on, that we try and define curved nature by two-dimensional space, and we never include the curvature, the breathing in, like Alan Watts said. No one would be attracted to a Euclidean woman because she would just be straight, all straight lines. It's the wiggliness, it's the curvature that brings the balance. Everything has to have the balance. You know, the electric side and the magnetic side. I can talk about it, but I can show you even better. If you could,
Can I stop you there? The concept of the periodic table, the way the periodic table conventionally is addressed, do they address these things as being isolated or intertwined?
they interact, but they feel that carbon will always be carbon, and it will have its half-life and keep breaking down, but it still be carbon. They don't understand that it unwinds and becomes nitrogen. Nitrogen unwinds and becomes oxygen.
So the periodic table, the conventional use of the periodic table, and what is this other gentleman's name again?
Walter Russell.
Walter Russell. Walter Russell's version of the periodic table. How is Walter Russell's version of the periodic table perceived by people who study this?
Well, now everyone wants to use it. If you can go to in my book, there's a picture of Einstein reading Walter Russell's first book, second book, The Universal One. Because when Walter wrote this in 1926, he sent it out to 300 different universities and physicists. And one of the quotes that Einstein says on his deathbed, I should have spent more time reading Walter Russell's work. That's how, and now they're taking it under their wing. But remember the Michelson-Morley experiment from 1887. They were trying to prove whether there was an ether or an effect of an ether, or the quintessence that everything came from. That used to be called the fifth element. That everything in that from antiquity, everyone understood that something doesn't come out of nothing. It's like when you look at the air, it looks clear, but you change the pressure condition, the balance of the change of pressure condition, we call that condensation. It creates clouds. And you change the motion conditions, whether it's moving quickly or slowly, it's going to become snow, it's going to become rain, it's going to become hail. So everything comes down to just one of two forces. Either you're breathing in and filling up something, or you're pouring it out. But the scientists, they ignored Walter Russell's work because he didn't include any equations inside of it. He talked philosophically regarding how things behave in comparison to laying down and following some Newtonian or calculus writing. He said he based things based on let's explore them naturally. And that's what I did with my book. What Walter Russell was missing, he didn't have the wave conjugation. He didn't have the mirror shapes, the all shapes. And that was because of a mistake that was made 6,000 years ago, maybe. They took the flower of life, which was that symbol.
Mhm.
If you could go to my book, tcotlc.com, there's an example that I put in there on page 64. And I show the period, I show the element, the fundamentals. If you could possibly pull that up, Jamie. It's tcotlc.com. You'll see in there the mistake that they made because they believed in straight lines, because the church was promoting the idea of straight lines. You just tap on right below there. You download. No, just go to the center of the page and right above that, and you see initial public draft, just tap on it. And if you go to page 64, on the right side of the page, right there, on the left side of the page, you see the 5 Platonic solids. Now, these, all of our axioms, all of our postulates have been built off of these things. This is what Euclid went down to Egypt and pulled these things together. Pythagoras worked on them. And these were the undisputed fundamentals of God that he used to build. If you tap onto the flower of life, Platonic solids things, it's going to take you to a video. Turn it, don't have to. It'll show you the flower of life that they took this from. But you'll see that instead of following the natural curvature of these 64 circles overlapping, they averaged the space where they met. And they invented straight lines.
Mm.
They
Why did they do that?
Because they believed that the world was flat. They believed the world was flat at the time. And the church promoted. Pythagorean theorem comes off of this cube, a squared plus b squared equals c
So
squared.
they wanted to use all of these intertwining circles and create straight lines.
Because that's how they thought everything came down to straight lines. They thought the world was flat. And I was like, oh my goodness. They didn't open the flower properly. So the next one would be the icosahedron.
Now, the flower of life, it's very, very old. The concept is very old. What was the origin of the concept?
It's the oldest symbol known to mankind. It's believed that it was Anki, the brother of Enlil, if you go by the Emerald
Sumerian
Tablet.
text.
Yeah, the Sumerian text, that was the one that created mankind. Because if you look at mankind, and there's a point I want to make with it. I want you to stay on the book, go back to go to 134 on the book. And this is what that other gentleman being told me to do. He said, why don't you just take the pieces that make up the flower and put them together based on universal ratios? So if you want to, able to pull it up, page 134. 134 in the book. So this is the juxtapose of the mistake they made. Yep, just tap right onto that. Yep, just tap on it. Now, this was made by David Johnson, one of our programmers, Argos Fuel. So if you go to the far left and tap on that, I took 4 of those triangles. And wow. And you can scroll around. This is what happens when 4 bubbles meet. This is the negative space where they can't touch each other. This is hydrogen. And as I was saying, electricity is always trying to get to the center of that triangle, but it gets pushed out. And now you see it has 4 contractive poles, which is the electric poles. Just go around from like horizontally. Yeah. It has 4 contractive poles because electricity is seeking a higher pressure condition and forcing it in, where magnetism is seeking a lower pressure condition and spun out. So the vortices, those tips, that's the magnetic field. That's where they begin. But it has an equal attractor and an equal amount of repulsion. So if you go to what happens when 8 bubbles meet, they gave me the patents to that. I call that the tetrahedron. This is
So this is the negative space in between 8 bubbles.
8 bubbles. This is a negative space where 8 bubbles meet, and you can scroll around.
And this is ignored when they're concentrating on straight lines.
Completely, because this, if you look from the top, I haven't violated anything. It fits perfectly inside of there. But this is a negative space where 8 bubbles meet, but you'll notice it has 8 contractive poles, but it only has 6 magnetic poles, 6 vortices, so it has a greater electrical potential than a repulsion. So maybe this is the strong nuclear force, and the previous one was the weak nuclear force. So I was like, okay, I called this the Huntian after my son. So I was like, what happens when 6 bubbles meet? If you go to the one right in the center. Now you see that it has these huge bubbles, fast moving, but there's 6 strong spheres that's going around this, but the greater attractor has grabbed the 2 weaker attractors. And this looks just like a photon, and guess what? It has 30 poles. What is the speed of light? 299,752,400 something. They rounded off to 300 million kilometers per second squared. But if you look at it from the top, you'll see that I haven't violated anything. This looks like what happens in nature. So I was like, okay, so they gave me the patents to this, but you'll see that there's 6 unaccounted electrical poles to it. So I was like, what happens when 12 bubbles meet if you go to the one right next to it? Another stable structure that we basically see in nature, but there's 4 unaccounted electrical poles to it. 4 spin around it. You can count those 4. You'll see 1 at the bottom and 3 on those sides. This is the basis of crystallization, laws of crystallization that forms. And you can go to the last one. I was like, what happens when 24 bubbles meet? This is a negative space. If you pull to a horizontal on it, this is a negative space where 24 bubbles meet. This is where you cannot distinguish this from the background because all of the electrical potential has been accounted for. This would be the Bose-Einstein condensate, where something becomes indistinguishable from the fabric of space itself, the final state of matter. Something, and the proof of this, the platonic solids, they have a thing called discrete symmetry. You can put the cubes together, maybe you can put the dodecahedrons together, but you can't put all of them together. But you can take the wave conjugations right here, and they form supersymmetrical systems where everything aligns. So there's a site that James sent over to you, and this will be the final thing, and then I'll be quiet for a second. But because this is the final, this right here. Now these are other sculptures I've built. There's a video, and you'll see that flower. If you pop it up from Terry's linchpins that he sent you, you'll see, and this was one of 4 supersymmetrical systems that I patented. And the reason I patented it was because when Walter Russell put his stuff up, you have to scroll down a little bit, and we're going to get to gravity, not that one. We're going to get to gravity in a second, not that one. We're not even there yet. There, Tetrotarian wave conjugations. Now, these are all of those systems put together. This is where 12 bubbles meet, the Albrians. And then I put 5 of them together, and they make these natural starfish. But then when I put 10 of them together, they lay themselves out, and they predict all distribution of matter within the electric field. And you can see where 6 bubbles meet as you get to a higher point on it. Those where 6 bubbles are meeting, still fitting perfectly where the 12 bubbles are meeting, and where the 4 and where the 8. That's a super symmetrical system. I put 12. If I put 20 of those where 6 bubbles meet, the Antonians, they make a natural dodecahedron that's naturally curved. If I take where the 12 bubbles meet, that's where I made the linchpin from. Ultimately, from some of those pieces you got right there, that all shape of it. So that was one of the first things. But when Walter Russell came out with his book, and he introduced his periodic table. He watched as different people went up and collected Nobel Prizes for deuterium, for tritium, for all these things that he had discovered. And I was like, okay, let me wait until the patents are granted before I'll talk about it, so that they won't be able to stop it. But what makes more sense? Were they invented straight lines in opening the flower? Or where you actually take the individual pieces of the flower and put it together based on universal ratios? Which one do you think is how the givers of that knowledge intended for us to use it?
Well, it makes sense because you're accounting for the negative space and the straight lines are not.
Bingo.
Yeah, that it must be something. And so, and then these are all physical representations that you've created
Yep,
that are all of those things.
same things. That's the Aubrian right there.
How is this received? Like when you talk to people about this?
Oh man, they first, because I didn't show them, I hadn't shown them. I introduced it with, let's talk about our fundamentals are a little bit off. There are no straight lines.
Right.
So I reached out to Neil deGrasse Tyson. Neil deGrasse Tyson. I saw him at an event up front, at Fox. And he was like, hey man, yeah, I'd love for you to come on my show, do my radio, do my TV thing. We love that. I was like, yeah, but I've got something I want to introduce to you. And it was only 36 pages. It was a treatise. And I told him it was controversial. And I sent him over the 36-page thing that had the wave conjugations in it. But I started it off with 1 times 1 equaling 2. And he went in on my treatise, wrote, redlined everything. He attacked that I had talked about Walter Russell and Victor Schauberger and John Keeley and Tesla as the people that I looked up to. He attacked them, but then he started attacking, the 1 times 1 equaling 2.
How did he attack them?
Oh, he was because I asked him. I said, under what conditions? I said it's illogical where the square root of a number added to itself would equal more than that number squared. But that's what happens with the square root of 2. That's what happens with most of the numbers. I was like, how is it that multiplication, if it means to make more and increase a number, how is 1 times 1 equaling 1 part of the multiplication table? Now, I understand that if you're seeing it one time,
right,
but we call that once. But the moment that you add the times in there, that multiplicative indicator, that means there's more than one. So now each equation is supposed to be balanced. That equal sign is supposed to show that there's a balance between these two numbers over here and a balance on this one over here. What happened to the other one in this equation? It didn't equate. And then I took the square root of that number. I took the square root of 2. Because all this started in 3rd grade. I was arguing with my teacher because we were talking about the square root of 100. Oh my God.
Is that your phone?
Yeah, that's my detox thing. I'm supposed to detox right now.
How do you detox? Detox on a timer? What do you do?
There's my wife got me these things, because I'm supposed to take this.
What is that?
And
Pure Body Extract
and there's another one.
Advanced Daily Cellular Detox. What's in this? Oh boy,
and this too.
What's in this stuff?
Just things to counteract the natural the metals that we have in our bodies that wear us out.
And you just take these periodically throughout the day on a timer?
I gotta do it now.
Okay.
I take a dropper, part of that dropper, and then 4 sprays, and it removes the parasites from your system. Like oil of oregano, like using oil of oregano instead of using antibiotics.
And have you felt an effect?
Yes.
Yeah. What do you feel?
Well, I used to have really thick, dark circles under my eyes. That's gone away in the last 6 months I've been using that. My skin, I'm 55 years old. I'm 55 years old and I smoke. Do I look like I'm
No,
55
you
years
don't.
old?
You look great. And do you think that's because of this?
I think, well, I'm going to show you a picture of what I used to look like when my wife met me. And I don't know if you could, she'd be mad if I threw this up, but she's a beautiful one. But this is what I looked like when my wife met me. I was 256 pounds.
Were you eating differently?
Um, I was, well, now I'm intermittent fasting. I follow her routine, but she turned me from that into this. It's like she shined up.
Yeah, you look about 15 years younger. Now.
Yeah, and that's because of her. I still smoke my cigarettes.
Why do you do that?
I'm a crackhead. I don't know. Everybody has to have some vice. Like Alan Watts said, you got to have some balance of beneficence and rascality to you.
We have a fan in here, by the way. If you want to smoke in here, you're more than welcome to.
I don't trust people, that walk around, people get so offended by gurus a lot of times and yogis because they think they're these calm and passive people. When they get angry, they're like, oh, that was a directed anger. That was a purposeful anger to wake you up to something. And then they find out they have a girlfriend. They find out that they smoke and they're like, oh, this is a lie.
Right.
But that's the real person. That's what I loved about Alan Watts. He had a wife and he had his mistresses. He ended up dying with it, one of his girlfriend and his wife, off in this little place. But he spoke the truth. He was honest. Life is about the give and take. There's a balance in there,
To be human is to be flawed.
It's to be beautiful.
Yeah, it's part of the beauty of us. And it's part of the why we create. I don't think you create from a perfect place of enlightenment. I think part of the chaos of being a human being is the beauty of the creation. It's why we create. The most fucked up people, the best artists are some of the most fucked up people. My favorite musicians, my favorite comedians, my favorite actors.
Yeah.
Almost all of them are fucked up.
Yeah, my uncle used to call it, he said, if you don't get any flower to grow unless you throw some shit on it.
So back to Neil deGrasse Tyson and his critique of
So
Tesla.
he threw shit on he was like, well, Tesla stuff worked, but Tesla was never really respected and out there, and I guess he wanted me to support Bohr or Schwinger or Feynman or any of those people. And I'm looking at the Feynman diagrams. I'm like, you made all these things up. You're basically doing the Mr. Spock thing. If you want to find the answer to something, then you cancel out all the possibilities, all other possibilities, and you root it down to one thing. So that means going through the whole universe to answer one question. And that's the problem with probability. That's the problem with Heisenberg uncertainty. That's the problem with Schrodinger. All of those were just these probabilities because they had taken the ether out. They forgot the electromagnetic wave.
Mm-hmm.
It had to have a medium in which it followed on. It had to have something in which it was moving on.
They don't exist in isolation.
No, they do not. And it cannot be the cause of its own action. An effect can never be the cause of the action.
Mm.
The chicken cannot the egg cannot come before the chicken. The chicken has to be there first in order to lay it. It has to mate. And what Einstein left out was the equal and opposite of magnetism. So when back to Neil deGrasse, when he wrote his response to my paper, and he said, if you have any other questions, you're going to have to see somebody else, and he wouldn't take my calls anymore. I was like, okay, so I wrote the book based off of those responses, and I reached out to another guy, Dr. David Tong.
So it'd be very, very interesting that would be his take as a public educator, that he wouldn't want to talk to you anymore.
The reason I wanted to talk to him was because of his show, The Cosmos, that he was doing after that incredible guy, Carl Sagan. The very first episode he had was talking about Giordano Bruno.
Mm-hmm.
And he said that Giordano Bruno was looking for that grand unified field equation, and maybe one day somebody is going to do it. And when they do it, it's going to change the world. And I'm like, dude, I've done it. I've got it here.